This video was made possible by Toyota. Ideas for good.
Tell you later, gotta work right now. Hey, if you use one of these, or one of these, or the electronics in any of those, well, it's only because 64 years ago, 3 guys out in Jersey invented this.
Meet John Bardeen, a mathematical physicist with an amazing grasp of electrons. Walter Bratton, a radio engineer who knew more about the atomic structure of solids than just about anyone. And William Shockley, a physicist who knew a lot about salt and who, rumor has it, was kind of a difficult guy to get along with. The 3 worked at Bell Labs, the research arm of the telephone monopoly that once ruled the wires in the United States. And what they came up with disrupted everything. They called their invention a point-contact 3-electrode semiconductive amplifier. But the world came to know it as a transistor. Trans, as in transmitter, or transfer, and sistor, as in resistor. This innovation would win them the 1956 Nobel Prize in Physics.
Well, since you personally own at least 10 million transistors, more likely several hundred million in your various devices, I thought you might like to know how they work.
A transistor is kind of like a remotely controlled valve on a garden hose. It can switch the water on fully, or shut it off completely, or it can control the volume of water that's allowed to flow. Now replace the water in your mind with electricity as we dive into the 3 parts of every transistor: collector, emitter, and base. The collector is the supply of electricity, like water under pressure. The emitter is the output, like the nozzle of our garden hose. And the base controls the flow, like the valve mechanism. By changing the amount of control current from the base by a little, you can change the amount of juice flowing from the emitter by a whole lot. So a transistor can be an amplifier. But it can also switch. So to use it for computing, on and off become the 1s and 0s of binary logic.
So now you know very roughly how a transistor works, but here's why it works.
It's the materials. The key is what you bake into the base. The emitter and the collector are both metals. They conduct electricity. But the base is what's called a semiconductor. It can conduct better than an insulator, but not as well as a conductor. And here's the thing. You can tailor-make a semiconductor's conductive properties. Depending on what's cooked into it, it can either carry a negative charge or a positive charge. A semiconductor is made out of what would normally be a non-metallic insulating crystal, usually of silicon or germanium. But by dirtying up that crystal with phosphorus or boron, you give that semiconducting base more conductive properties. That's just what Bardeen, Bratton, and Shockley did back in 1947, and they used it to go where no electrical engineer had gone before. They chose germanium, doped so that it had an abnormally high electron count, therefore a negative charge. So it's called an N-type semiconductor. Bratton fitted a strip of gold foil across the apex of a plastic triangle. He sliced the triangle's tip with a razor blade to form 2 contact points, spaced less than 3/1000th of an inch apart, as Bardeen had told him they needed to be. And he suspended them so that the contacts just touched the crystal of germanium. And when they put a small electric current through one of the contacts onto the base, it was like herding agitated animals into a pen. The signal kicked subatomic holes, basically the opposite of electrons, into the facade of the crystal, which changed the semiconducting properties so that a completely separate and much larger current instantly began flowing from the second contact. Now, remember, these Jersey boys worked for Bell Telephone. So they connected a microphone to give some complexity to the small current, and connected a loudspeaker to the larger current flowing from the second contact, and our world has never since sounded the same. Years later, Bratton would say,
The only regret I have about the transistor is its use for rock and roll.
And for the innovators, I'm Dave Brody.